Welcome to Accelerated Solidworks 2025 Learning, Lesson 14. Under the Desk Drawer Practice 2. Okay, let's open the Solidworks and then open the drawer parts drawn in the previous lesson. The file drawer can be found in the recent documents in the software welcome screen. Or you can press this open button, then find the folder under the desk drawer and double-click on the drawer to open it. This is the model we drew in the last lesson. The triangle structure on the left and right side is combined with the guide rails so that the drawer can be dragged back and forth. So in this lesson, we will design the rail. Let's use Ctrl+N, create a new file, and then select the assembly icons. Notice that it is the second icon, and make sure that the new assembly is created. On the left is the option box to insert parts. Below here are the drawer parts that we need have just opened to choose from. Just as we need to add this drawer part to this assembly, we select it and then click OK directly to insert here. Kelvin would like to explain that there are many friends who add the first part. First select the part and then move the mouse to the view area to add this part to the assembly. This is not a good way to do this because adding part in this way will cause the first part of the assembly to be inconsistent with the default coordinate system of the assembly, which can cause some confusion for subsequent design. So we must click this checkmark button to add the first part. After adding it, we see the assembly design tree on the left. The part and the assembly coordinate system are unified. In fact, the three default planes of the part and the assembly coincide with each other. We can click on these 6 planes in turn, and we can see that the corresponding planes are overlapping. The 3 planes of the first part coincide with the default planes of the assembly, which is a great help for subsequent design. For example, if the 2 right datum planes coincide, the part is symmetrical with respect to both right datum plane. In addition to the fact that the first part coincides with the coordinate system, there is another point that we need to understand, that is, this part is fixed by default and cannot be moved. Okay, the first part of the assembly has been added, and we need to save the assembly before we start the subsequent design, so that we don't have a situation where the computer crashes. The shortcut key to save the file, we also save it in the under the desk drawer folder name set to the under the desk drawer assembly to save. And then we also officially start the design of this lesson. We design real parts. In the past, we used to create a new part and then add the part to the assembly after the design is complete. But this is not the case in our practical course. Let's close this window first, and we see the view area. The junction of this rail and the drawer is the same profile. If we can create a new rail parts in the assembly and then use the outline of the drawer as reference of the track design, then the design is very simple. The above idea can be implemented in Solidworks. So let's follow Kelvin's operation. We find this button to insert a part in the assembly bar. And then we click on the triangle button below. And then we click on the second button, new part. Okay? And we have a new part added to the assembly. After creating a new part in the assembly, the next step is to select the sketch plane of the part. We draw in a front datum plane of the assembly. Click on the front plane of the design tree and see that the new part name below is blue, indicating that it is in the state of being edited. Again, the sketch button is also activated. Then we can start sketching. Click on the front plane. Click on the button in the pop-up menu. Normal to the sketch plane and follow me to sketch. Activate the line with mouse gesture. Draw a vertical line from the origin upward. Then alternate plus C to set the line as the construction line. And then draw it to the left. At a position about the same as mine. Then diagonally downwards. Then down a short section. And then deflected to the right. And here there is a perpendicular geometric relationship. I don't want to have this perpendicular geometry, so move the mouse down a little bit, well, so there's no more. So determine this line and then exit the line sketching. We need to extrude through this sketch to get the drawer rails. Continuing with me in the next step. Add relations. Hold down the Ctrl key while selecting the edge of the drawer in the last line segment. And click Make Collinear in the shortcut menu so that they coincide. This is where the drawer meets their rail. Zoom in a little and continue to set it up. The two lines need to be parallel, and we still need to select them at the same time with the Ctrl key, and then set them to parallel. Okay, now that the geometry has been added, please check if your geometry is the same as mine. The next step is to activate Smart Dimensions and start marking the distance between the two vertical lines. Set it to 0.5 mm, and the distance between the two diagonal lines is also set to 0.5 mm. And finally, the distance between these two lines is 5 mm, which is the distance between the drawer and the bottom of the drawer drill. And now that we see that the sketch seems to be fully defined, then we are really ready to mirror the sketch on the left to the right and take a closer look. Okay, do you see this place? This point is still blue. Drag this point and find that it can be dragged. Then we need to define it. Drag this point back. Activate the Smart Dimension again. Click on this point and then click on this edge next to it. Set the distance by 1 mm. And now this sketch is fully defined. Next, we mirror and click the Mirror Entity button in the sketch bar. First, select the sketch on the left and select the one that needs to be mirrored. Then activate the Mirror Axis box. Click on the construction line on the right, and now the preview will appear on the right, and the mirror image is complete. Then we can use this sketch to extrude out the rails. Select the feature bar, then click the extrude workspace button, and now a preview of the extrusion appears, where the thin wall feature is automatically activated. Look at it again. The thin wall feature is not oriented in the right direction. It should be outward, not inward. We click on this reverse button here for the thin wall feature, and now the preview has changed. Adjust the view angle with the middle mouse button. Let's see that this default 10 mm is too thick. We change 10 to 4. After Kelvin test, 4 mm thickness is no problem. Then let's look at the direction of the preview graphic extrusion. No, it should be towards the inside. We click the reverse button under the direction 1. The direction is right. Change the extruded distance to 200 again. Press the keyboard Enter key to refresh the preview, and the effect of guide rail will come up. We make sure that this extrude is made so that this rail part is built up, and you can see that is this second part in the design tree, which hasn't been named yet, and it is not safe. Then we save this part. Right click and then click Save Part in the menu. In the pop-up window, make sure that the save part needs to be saved in the same folder as our previous part. I have no problem here. Then double-click Part 2 to rename the part. Enter a name rail and make sure the part is named and saved. Notice that it is still blue in the design tree, indicating that this is in an edited state. We click the Submit button in the top right corner to confirm the edit, and then save the file in stages. If we look at the model, this drawer should be able to move back and forth in the rail. But now in our model, this drawer cannot move back and forth. The software prompts that the part is a fixed rail, and the part cannot be dragged either. And the software prompt is fully defined too. And we can see in the design tree that the name of the drawer parts of the assembly is fixed by default. In the second part, this rail part can't be dragged. We click on its drop-down menu to see it made first, which show that it has an in-place made. And the front plane is highlighted because this part is a new part in the assembly. Its default position is the position of its first sketch, and the first sketch of the rail is drawn in the front datum plane, which is certainly not moving, so the guide cannot be dragged. If you want this part to be dragged, we can delete this in place made, but in our work we generally don't delete this in place made, and we don't want to click the delete button. We keep this in place made. Let's analyze this rail. It is attached to the bottom of the table. It is not moving. The part needs to be moved is this drawer. And if you want to move, we can right click on it, but we still don't want to do it because the first part of the assembly is a very important benchmark. Once it's moved, this is like a house with a moving foundation. So we really don't recommend it. So what should be done to simulate the pulling action of this drawer? We can copy the part of the drawer, not holding down the control key of the keyboard as I did, and then drag the drawer parts in the design tree to the view area. In this way, the drawer is copied out, and the drawer part can be dragged with a bar in front of its name, indicating that the position of the part has not been completed. Define it. Then select the first part, which is the fixed drawer. Click on it, and then click the hidden button in the shortcut menu to hide it. We have just gotten a drawer part that can be moved by duplicating the part and hiding the original part. Okay, so let's get down to business. The drawer part is too free now. It should be slide inside the rail, and we need to fit the drawer into the rail. When the drawer is pulled, the two set of face on this side rub against each other, and the right side is the same, and the opposite side touches each other. Then we make them well by appropriate constraint. Click on the Make button in the assembly bar. After entering the Make, selecting the core inside, Make here, and then select the face of the core incident Make. First select this face of the guardrail. Click, and then switch the perspective so that we can select this face under the drawer. This is this face. Click. The drawer still moves. These two faces are overlapping. No problem. Just click this checkmark button to determine the coincident made. Then we move to the right to make these two surfaces coincide. These two faces are glued together. How do we select this face on the inside of the rail? If you had the same problem as me, let's exit the make state first, and then drag the drawer like I did, so that they are separated first, so that both sides can be selected. After the adjustment, click the mate, return to the mate again, and select the face that coincide with each other in turn, and they will coincide. Confirm the coincidence and click the check mark again to exit the mate state. We switch to a convenient viewing angle, and now we drag the drawer. And hey, the drawer slides through the rails, but there is no limit to how far it can slide back and forth. In fact, the drawer must only be pulled out at a certain distance, which requires a mate to limit the opening and closing range of the drawer. Please do the same as me. Move the perspective view to similar position, and then drag the drawer to the outside. which is the same position as mine. And then now click on the mate, click on the advanced, and then go to the bottom to find this button, which is the distance limit button. Click on this mate can help us set the opening and closing limit of the drawer. First of all, you can see that the above is the same as a normal coincident mate. That is, you need to select two faces that mate with each other, and then let these two faces move within the set distance. Then click on the outermost side of the drawer and the innermost side of the guardrail in turn, as I did. These are the two highlighted faces, and then go to the bottom. Here is to set the minimum distance between these two faces. Here it should be 0. Press the enter key after setting. The maximum value we set 180 mm, and also press the enter key. This is the distance made in the advanced made. After setting, click to confirm the exit of made. We drag the drawer to take a look. Well, this drawer can only be pulled within the specific range. We have just implemented the pull out function of this drawer by using two coincident mate and a distance limiting mate. Now when we see the drawer, it feels quite awkward because this drawer is still a solid one and it can't fit anything. So the next step is to hollow out this drawer and make it a drawer for things. We click on the drawer in the design tree and then click on the edit part button in the shortcut menu. When you enter the editing state, the part name is blue and the other part become transparent. Note that the prerequisites for modifying a part in an assembly is to first bring the part into an editing state. When Kelvin first learned this software, he often wanted to modify a part, drew a sketch for a long time, and find that he had not yet entered the situation of editing the part and waste a lot of time. So we have to have a mind when we modify the part. We have to make sure that we are in the editing state of the part before we do the next step. We draw a sketch on this surface. We draw a rectangle, and after the drawing is completed, we can cut out the pocket of the drawer through the sketch. In addition to drawing rectangles and redimensioning, we can also quickly obtain them with offset solids entity. Let's select this face first, and then click the offset entity button in the sketch bar so that there is a preview of the offsetted edge. Now it is 10 mm offset, a bit big. We change it to 3 mm and then look at the preview. This distance is outward. This is not right. It should be inward. We check the reverse in the property box. Now there is no problem with this preview. Following the mouse can be given to you next. I believe you also know how to operate. Click on the extruded cut in the feature bar to observe the preview. There is no problem with this direction, and the depth of the cut is definitely wrong. We choose which end condition is appropriate. Here, we can select offset from face. After change the perspective view, we need to select the bottom surface of this drawer, which is this side. Click and then set the distance to the left, changing 10 to 3. Let's take a look at the preview. No problem. Then we will look at this extruded cut. Okay? We empty the drawer with this stretch so that the drawer will keep holding. Notice that when we plan on the paper, there is a partition in the middle of the drawer. We design it with an extruded boss. We click on the bottom of this drawer and then click on Sketch in the shortcut menu. After entering the sketch, we activate the line and then draw a line from the midpoint of the outline below all the way to the end. Exit the line and we can use this line to make a thin wall feature extrusion to make a partition. Below, we click on the extruded box base of the feature bar. Here there is an option box to close the sketch to the edge of the model. Here we click No. Here the thin shelf feature is automatically activated. And then here the end condition is changed back to blind. Change it to up to surface. The next step is to select the desired surface. That is the end surface. We need to click on this side of the drawer and change the angle so that you can observe. This is the top surface of this drawer. Click to select. Now the preview appears left and right. To observe this preview, we can see this thin wall feature is on the right side. And we can see the property box of the line, which is set to one direction here. And here we change it to mid plane. Then we set the thickness to the same level, or 4 mm, so that the preview is intuitive. Determine this extrusion, and now the drawer is divided into two parts. We click on the view direction in the view tool, and then select the top view, and look at this drawer from the perspective of the top view. This drawer in the design tree is still blue, indicating that it is still in the state of editing. Click on the triangle button to open the design tree of the drawer. We just cut it by extruded cut it so that the drawer can store things. Let's click on the extruded cut triangle button. And below is the sketch of this extruded cut. Every step of our design model is visible in this design tree. After the extruded cut, we just did another extrusion, dividing the drawer into two parts. And this extension was extruded out by making a thin wall feature with a straight line. Okay, let's take a look at the view area. Do you feel that this drawer looks very narrow when it is divided? Click on this line. We can see in the lower right corner of the software that its length is 55 mm, which feel a little narrower. And the distance between them can also be set by selecting the left and right side. I think the width of 55 mm is too narrow. So there are too few things to put in this way. And it is not convenient for me for the hand to reach in and get things. So we need to modify the width of this drawer and make it to a little wider. At this time, some students say, didn't they plan the width of the drawer of paper before? Why do you need to change it? Can't you design the size of each part and then model it? In fact, the design is inevitably modified and changed. The designer finds problem in the process of design. The project manager has suggestions for the design, and the customer says that a new function needs to be changed. Even after the design is completed, we will find that there are many things that needs to be improved. So we take practical classes to understand the actual situation of design, which is of great help in our actual design. Okay, let's go back to SolidWorks. Let's see how to widen this drawer. And we need to have a general understanding of the modeling process for this model if we modify the model. To know what determines the width of this drawer, you can pause the video and think for yourself. Where will need to modify the width of this drawer? Well, the width of this drawer is determined by the sketch of its first feature. Click on the sketch to see the dimension of the sketch. Modify this dimension to adjust its width. So we click on this sketch in the design tree and then click on the first icon in the shortcut menu to edit the sketch. And we go back to the sketch drawing interface. We just need to modify this 60 mm place. According to my research, to change it to 77 mm is better. Now the sketch has been widened, but another problem is as reason this drawer has becoming wider, shouldn't this guide rail also have to be widened? Now there is an error in the design tree. Don't panic, just like me. Submit this sketch first. Click submit in the upper right corner. Well, as the width of the drawer changes, the rail widens with it, and the design tree error message disappears. So let's substitute the part edit first, then analyze it together. First, the sketch of the rail in the design tree. We select it, edit the sketch, and we take a look. Oh, and it turns out that this sketch was drawn with reference to the drawer parts. So the drawer widens and the guide rails will widen along with it. Hey, have you noticed that we expanded the design in this assembly? If the design is done properly, modify this part and the other part can also be changed along with it so that our design is much easier. Now let's submit the sketch, edit, and then the part edit. And now it is much more comfortable to look at the width of the model drawer. Click on this sideline. The width of this side is 72 mm. No problem. Close the drawer and then pull it out again. Well, this drawer is just like that. Then we can start to design the small drawer inside the drawer. And then we create the small drawer. Click on the triangle button below the insert components in the assembly bar and click on the new part. The next step is to determine the drawing plane of the first sketch of this part. This little drawer is in this position, and we still create this drawer by extruding. Then we can select this surface as the drawing plane of the sketch. And after drawing, we can also extrude this small drawer out by extrusion and click on it in the view tool to view the normal to the sketch plane. Let's draw the outline of the small drawer to activate the straight line. Please draw like me here. Draw a horizontal line here on the left side up, then diagonally to the upper left up a short section, and to the right. Be careful to avoid perpendicular relationship to each other, and then up this endpoint coincide with the top surface of the drawer, and then draw to the right. By the way, this sketch on the right side can also be mirrored similarly in the past. So we end the drawing of this line here, and then we draw the vertical line down as the axis of symmetry. Hey, here we are stuck by the end of this line. We can move the mouse to a little bit below to end to keep the line upright. This line needs to be set to the construction line, and when select it will be used as the construction line. Seeing the line here, this is redundant here, and we need to trim it out via the trim entity function in the sketch bar. In the left property box, confirm that it is a power trim, and then hold down the mouse and swipe here, and this access line segment will be cut out. We will exit the trim sketch to the step, and we will add the relations. This is parallel as the beginning of the lesson. Select these two lines by holding the control key and then set them to parallel. And the above two diagonal lines are also set to parallel. And the geometric relationship of the other line segment is no problem. Then the next step is to mark the dimension. Activate the Smart Dimension and click on the line segment below and the line segment above to mark the height of the small drawer. After Kelvin's research, it was set to 19 mm, which can fit most pens and stationery. Then label the distance between this line and the edge of the outline. Here we set it to 4 mm, and then to the distance between the two vertical line segments above, we set it to 5 mm. Then there are two lines above. If the outline line here is not easy to select, we can enlarge it a little more. After highlighting, you can set the distance between them by clicking the mouse. Here, this is also set to 5 mm. In the video, please set it to 5 mm. And then mark the distance between these two lines. 1 mm is also marked here. And it is also 1 mm. Of course, it is also possible to make this line collinear with the line segment below. Select these two lines with the control key and set them as the collinear line so that the sketch here is fully defined. And now it can be mirrored on the right side. Click on the mirror button in the sketch bar. Then select the sketch. And then click the mirror axis option box to select the construction line so that the section profile of the drawer comes out. We notice that the line segment on the right side is still a blue. By dragging endpoint, and find that it can slide left and right, indicating that its width has not been set. So we switch to Smart Dimension and mark the width of this drawer. Here we set it to 77 mm, so that the width of the small drawer is also half of the width of the large drawer. And here we are also need to leave some space for the left side of the track, which also needs to be designed here. We first extrude the solid body out from the sketch, and then click on the extruded boss base in the feature bar, and then we can switch the angle of view so that we can observe the extrusion. We need to modify the aim condition to a given depth distance, just like the big drawer. Set it to 200. But now this direction is wrong. It should be inward. Click on this reverse button in the feature bar and there is no problem. Okay, we are sure that the initial outline of the drawer is now designed for this extrusion. We submit the part edit and now the part hasn't been saved. Let's look at the design tree. This is the part of the small drawer, but it hasn't been saved yet. So let's save it. Right click and click Save the part name. We change it to a small drawer. In this lesson, we design a track in the assembly body and let the drawer able to slide in the track. And finally, design a small drawer. When we look at the view area, I feel that these parts are too bright and a little uncomfortable to look at. Their color can be modified in the same way as Kelvin. Select the part in the design tree, then click the triangle button next to the appearance. Click the guide rail. We set the color of the part level of this part. Here, select the last button in the third row. This gray looks okay. Click OK for the second and third part. We can select it and paste the appearance in the shortcut menu, and then paste the appearance we just set, so that the gray appearance looks good. That is all for this lesson, and in the next lesson, we will design the wheel of this small drawer so that it can slide like a large drawer. Finally, we save the model, and we will see you in the next lesson.